Okay, hello. This is a video discussing section 4.3, the chemical equation and the information that it conveys. So in this section, what we're going to do is we're going to look at the general idea of what a chemical equation is, and then what are some common types of the chemical equations that we might see out there. So first of all, I want to point out that in the previous section, we talked about something called a chemical formula, right? And what I said was that a chemical formula is just a way of representing how many atoms of each element are in some substance, whether it be a compound or a polyatomic ion. So that's the chemical formula for water. Another example that we could do is iron 3 chloride. So that would be the chemical formula for FeCl3. You can kind of think of it like, what's the formula for your shampoo? You would be essentially saying, what substances are we putting in there? In the chemical sense, the formula is generally for one of those ingredients, one of those substances, okay? So that's the chemical formula. The chemical equation is different though. The chemical equation is showing something changing. So the chemical equation it uses chemical formulas. We'll have chemical formulas in them. So we use the chemical formulas to represent what we call chemical change. And we usually introduce chemical change right at the beginning when we think about matter. There's physical changes and chemical changes. Sometimes it's hard to tell which one is which. A chemical change is something where the chemical composition of the substance changes. So for example, if I take hydrogen peroxide, we all know what that is, right? We've used it before. It has the chemical formula H2O2. Okay, all right, H2O2. But that's pretty close to water, right? Water is H2O. And both of them have in common what we would call oxygen. And I'm going to write oxygen as O2. Normal oxygen that we breathe and that we interact with, if it's by itself as an element, it's actually O2. It's not O, it's actually O2. It's called a diatomic element. There's several diatomics. There's 7 of them in nature. Oxygen happens to be one of them. So we breathe in O2, not O. Now, those substances, those are the chemical formulas for those 3 substances. It turns out over time, hydrogen peroxide will undergo a reaction where it is slowly converted into water and oxygen gas, okay? This is what we call a chemical equation. We have a formula, then we have an arrow, and then we have new formulas, different formulas. The atoms on the right, the elements on the right, also have to be on the left. They have to be on opposite sides. Because in chemistry, an element can't be created or destroyed, can't destroy or create atoms, but we can rearrange them. Effectively, what's happening is there's 2 oxygen atoms bonded to these little hydrogen atoms like this. And this molecule is falling apart. It's doing what we call a decomposition. It's breaking up into an oxygen and a hydrogen, and then another oxygen and a hydrogen. Okay? The little one is hydrogen, the big one is oxygen. So there's 2 OHs. And what happens is, if we had another peroxide, hydrogen peroxide, it'll break up too. It'll break up into another OH, OH, and another OH. Okay, so you have from 2 hydrogen peroxides, you get 4 of these OHs. Okay, now those OHs, they will rearrange as well. Okay, and so what will happen is one of these hydrogens will pop off of here and go on to that oxygen. And when that happens, it's like a second reaction, right? Now we have a hydrogen, an oxygen, and another hydrogen, and that's water. Okay, so that hydrogen pops off and onto the other oxygen. Now you got a water, and now you have just an oxygen atom all by itself. Same thing over here. This hydrogen pops over to that one, and now you got H2O. Okay, that's a water molecule, right? H2O. And you have this other oxygen atom, the one that lost the hydrogen. These two oxygen atoms then can find each other, they collide with each other, and they form O2. So it's pretty complicated, right? Several steps occurring in that process. But the point is that the water and the oxygen come from the hydrogen peroxide. The hydrogen peroxide is the starting material. We call it a reactant. The water and the oxygen are the finishing materials, right? They're what we call products. They're the products of this reaction. And this whole thing is called a chemical equation. The chemical equation is kind of like an algebraic equation. We used to write it this way. We would say H2O2 equals H2O plus O2. And that's not exactly right. We'll get into the next section why that's not exactly right, because there's an issue with the number of atoms here. That's section 4.4. But get used to the notation. The formulas together showing you reactants to products, that's called a chemical equation. The arrow points toward the products, okay? That's the rule, not that it points to the right side or up or down. The arrow points toward the products, the finishing point. So this is change, right? Chemistry is the science of change. Really, all sciences are the science of change, but in particular, this is the science of change. So atoms are rearranging, making new substances. That's called a chemical equation. There are a few things that you will want to be aware of, which is that sometimes we will indicate what state of matter they're in. So this, if it's dissolved in water, we would write AQ, dissolved in water. If it's a liquid, we would write L. That means it's a liquid, right? And that's different, right? Dissolved in something like salt dissolves into water is not the same as the water. The water is the liquid. The salt is dissolved in the water, so it's aqueous. But if we cool it down and we freeze this into an ice cube over here, we might have a solid, right? H2O solid. That's for the water. It's an ice cube, right? Solid water. Oxygen, as we know, as we breathe it in, is actually a gas. So these are states of matter. And sometimes we write them into the equations. We might or we might not. Here I'm going to aqueous, liquid, gas. Obviously, that depends on the conditions. We could have solid water, ice, or we could have liquid water, or we could have steam, which is gaseous water. Okay. Another thing you might see is you might see a, let me erase some of this. You might see a little delta sign, looks like a triangle. And in our calculations, we said that meant change in. Kind of means the same thing here, a little bit different though. Here is an example where you would see it. The little triangle appears above the arrow. Okay, so again, this is clearly the reactant because the arrow is pointing away from it. These are products because the arrow is pointing toward them. The arrow points towards the products. This little triangle is referring to heat. That means we're adding heat to the reaction. Some reactions do not occur unless you add heat. You have to use a flame to get them so hot that they will do that. So that degree, I'm sorry, I kept calling it degree. That triangle represents in this context, we're adding heat, usually through a flame, but it could also be just like putting it in boiling water. That would be a way to add heat. And that's a symbol you use. There's another symbol, which is, you may see this above the arrow. in that case, that means that you're using light. These are photons. Those are representing photons. So that's light. Okay. Light has energy. Photons have energy. So this is saying that in order for the reaction to occur, we have to provide energy for it. And that's through the form of photons. We're just shining light, a laser beam on it or a light bulb or something like that. There are some reactions that require that. Okay. Now, what I want to do is I want to show you some classifications of reactions. There are many ways to classify reactions, different types of reactions. So really, when I say classifying, I mean, like, imagine if I said I'm going to classify animals, I would have dogs and cats and pigs and cows. That's classifying animals. We do the same thing with chemical reactions. And so I'm just going to show you a few of them. The first one is called a combination reaction. And generally the combination is you take something, you add it to another thing, and you get one thing out of it that's more complicated. Okay, so that could be something like Cl2 as a gas, H2 as a gas, HCl as a gas. That would be called a combination because you're taking two simple things, two elements, and forming a compound out of it. So two simple things make a more complicated thing. Here, there's a second type of reaction, which is called a decomposition. Decompose. So there's combination, combining, and then there's decomposition. Okay. In this case, it's kind of the opposite. What you're doing is you're taking something that's more complicated and breaking it up into two simpler things generally. Okay. So actually, I showed you one just a moment ago. If we take calcium carbonate, CaCO3, and I heat it, I have to add heat for this to occur, I get calcium oxide, solid, and carbon dioxide, gas. See how that's decomposing? You're taking one thing and breaking it up into two things. That's called a decomposition. Okay. The third type is what's called a single displacement. Now, some people call them replacement, which is fine. I'm going to call them displacement right here. Okay, actually, your textbook uses replacement. Okay, in this reaction, what happens is you have something like an element reacts with a compound that has two parts. Oops, sorry. Let's use different symbols. So see how this is an element? And then this is a compound. A compound has two or more elements, right? So if it's BC, that means we have two elements, at least two elements. What happens is one of those elements will combine with the single one and then leave the other one by itself, right? So this is what we're claiming is that A is displacing or replacing C. C is with B, now it's all by itself. It got replaced. It got displaced, okay? So the element that's by itself at the beginning as a reactant is now with another element at the end as a product. It displaced the one that went away, that got separated, okay? So an example of that would be something like this. Zinc, copper sulfate. And what's going to happen here is the zinc is going to combine with the sulfate. And then you're going to have the copper all by itself. Okay, so essentially the zinc displaced or replaced the copper. The copper is all by itself. Okay, so element plus a compound. Remember, it's polyatomic ion in that one. And then the fourth one is called a double replacement or double displacement. I'm going to stay consistent, called displacement. But again, it may be called replacement depending on what book you're using. Okay, so these ones are pretty common. I'm going to show you one example. Oh, let me show you the general formula. The general formula is AB plus CD. So each reactant has two parts. Okay, so now the A is going to go with the C, and the B is going to go with the D. Okay, so an example of that. Oh yeah, right. I was going to show you an acid-base one. HCl plus NaOH to form H2O and NaCl. So H plus Cl minus, Na plus OH minus. Remember those polyatomic ions, OH minus. The H plus goes with the OH minus, and the Cl minus goes with the Na. So Cl minus Na. I wrote this as H2O, but it's really H plus OH minus. Right? H plus OH minus is what that is. Okay, so that's called a double replacement or double displacement. So one part combines with another part. Generally, actually, I should rephrase this here. It's generally the first part goes with the second part, and the second part goes with the first part here. I'm sorry. Okay, does that make more sense, hopefully? So remember, we usually have metal, non-metal, or cation, anion. So cation is going to go with an anion, and anion is going to go with a cation. So that's why it's in that particular order. Okay, let me show you a couple of examples. They give you several questions here. There's actually 8 little questions, 4.5 and 4.6. So we call them questions. So here's question 4.5. I'm just going to do a couple of these. So what they do is they show you, I'm going to do B to begin with. Al plus 3NiNO3 goes to AlNO3 3 plus 3Ni. Don't worry about those numbers in the front. We'll deal with them in the next section. And they just ask you to classify. Is this a combination, decomposition, single replacement, or double replacement? Okay, so you just go through your 4 possibilities. So for something to be a combination, 2 things combine to make 1. Well, that's not what we have here. There's 2 things forming 2, so it's not a single, it's not a combination. Decomposition is where something breaks into 2. So if you look at this one, there's 2 reactants, so it can't be a decomposition either, because a decomposition is 1 thing breaks into 2, generally. It could break into 3 as well, but generally it's 1 into 2. Single replacement is where you have 1 element by itself, and then it's reacting with something to have 2 together, 2 parts, and then the one that's alone by itself at the beginning is now combined with one of the 2 partners at the end. And that's what happened here. The aluminum is all by itself. Now it's with the nitrate, aluminum nitrate. So single replacement, right? There's our answer right there. Okay, the double replacement would be where you have the first one has 2 parts and the second one has 2 parts and they just switch partners. So let me show you another one. So this one is, that was part B. Let's do part C. KCN. I'm not showing the states of matter just to save a little bit of time. HCl is going to HCN and KCl. Okay, let's see. So it looks like each one has 2 parts here, right? H plus Cl minus, K plus, this is called cyanide, Cn minus. It's a polyatomic ion. Okay, so 2 parts, switch partners. K goes with the Cl, KCl. H plus goes with the Cn minus, HCN. So there's your double replacement. Okay, so single replacement, double replacement. There must be a decomposition in here. So let's do question 4.6 and let's do B. So B is Fe2S3 is being heated to 2Fe plus 3S. Take a look at what happened here. One substance breaking into two, decomposition. Okay, let's look at question 4.6D. Carbon plus O2 in heat goes to carbon dioxide. One element, another element, the two of them combining together, combination. Okay, so you can practice those questions 4.5 and 4.6. There's 4 parts to each of them, and that'll give you a pretty good sense of this classification. Now, I do want to make a comment about this classification system, which is that there are other systems that are used. So sometimes we think of things as producing water, we call them condensation, sometimes even a dehydration, water reacting, so we call that hydrolysis. There's different ways of classifying reactions. One is called acid-base reactions, another is called oxidation reduction reactions, precipitation reactions. We'll look at those later in the chapter. But this is just one classification where it's kind of simple because you're just looking at, is it A plus B, C, or is it AB plus CD, or is it AB goes to A and B, or is it A plus B goes to AB, right? Those are your 4 possibilities there.